Good morning, children. Let us start with our last lesson, probability. Okay. So, to measure the lack of certainty or uncertainty, there is no perfect yardstick. In that situation, we are using the numerical measures as probability. Okay. So, we can't predict it whether it happens or not. Okay. In that cases, we are selecting that as probability. For example, for weathercasting and all, you know that they will say that in news and all for weathercast prediction today it may rain or not. Okay, may or may not happen. Okay, in that cases and all we are applying our concept probability there. Okay, so last year you studied how to find out the probability of an event. How to find out the probability of an event? We will find out the probability of an event by first we will consider the favorable number of favorable outcomes and total number of outcomes. Okay. For example, if we are tossing a coin, head or tail will come, isn't it? So the sample space it contains 2, that is our total number of outcomes. If we are tossing a coin, head or tail will come. So we know that the total number of outcomes as 2. Suppose I am asking you, what is the probability of getting a head turning up? Okay, so for tossing a coin, we know that n of s, the number of sample space elements are 2, and tossing a head turning up, we are getting a head turning up. That means if we are tossing a coin once, only one time a head will turn up, isn't it? So we can say that probability of E is equal to, let E be an event if I am considering that, means we can say that probability of E is equal to n of E divided by n of x. Here n of E represents the number of favorable outcomes. Number of favorable outcomes divided by total number of outcomes. Total number of outcomes. So, a probability example, tossing a coin. So, tossing a coin for getting the head turning up. Getting head. How to find out getting head? Getting head turning up. So, we will write that. Let E be the event of getting a head turning up. Let E be the event of getting a head turning up. Turning up. So we can say that probability of E. E be the event of getting a head turning up. So n of E, how many times it will happen? Only once, isn't it? N of S, total number of outcomes, head or tail. So 2. So n of S is equal to 2, n of E equal to 1. So probability of E is equal to n of E divided by n of S. That you can write, instead of this formula you can write number of favorable outcomes divided by total number of outcomes, because in our textbook they are given like this manner. So you can write like that. Why I am giving like this means in your higher classes they will give the probability in terms of sets and all. Okay, so that is the reason I am starting here itself with this one. Okay, so probability of E, n of E by n of x, that is equal to 1 by 2. So see that whatever be the sums if you are doing, we will get the probability lies between 0 and 1. Okay, it will not exceed more than 1. So we can say that the properties of probability, we can say that the probability of a sure event is 1 and the probability of an impossible event is 0. For example, if I am having a box full of 2 colored balls, okay, blue color and orange color balls are there in my basket. The total number I am given as 25. Okay, then I am asking you, what is the probability of getting a black ball? See that blue and red. That only I said. Blue and red two colored balls are there in that basket. I am asking you to find out what is the probability of getting a black color ball. So black color ball is not in that basket. You know very well, isn't it? So it is an impossible event. So we can say that and probability of an impossible event is 0. What is the probability of a sure event? Probability of a sure event is 1. So we can say that probability lies between 0 and 1. Probability of an impossible event is 0. Probability of a sure event is 1. So 0 less than probability of E less than or equal to 1. That means 0 less than or equal to probability of E less than or equal to 1. That means probability lies between 0 and 1. If it is 0, you can say that it is an impossible event. If it is 1, you can say that it is a sure event. Okay. So in examination, find the probability of lot of questions are there in exercises and all. If they are asking probability, if you are getting the final answer as more than 1, your answer is wrong, because we know that probability of a sure event is 1. It will not exceed more than 1. Okay, children. So let us see with the exercise sums. Look at the first question from exercise. In a cricket match, a batsman hits a boundary 6 times out of 30 balls. Exercise 15.1, first question I am reading. Find the probability that she did not hit a boundary. So what is the total number of outcomes here? How many balls are there, children? 30 balls. So total number of outcomes equal to 30. Number of favorable outcomes. What are the number of favorable outcomes here in the given question data? 6. So out of 30 balls, 6 balls are favorable to her. Okay. So what is the probability of getting? So I am considering that let E be the event of getting a batsman to hit a boundary. Okay. So let E be the event of hitting a boundary. Therefore, N of E equal to how many times? 6 times. Probability of E, N of E divided by N of S. So, N of S represents this total number of outcomes, that is 30. So, N of E 6 divided by 30. 1 6 is 6, 5 6 are 30. So, the probability of hitting a boundary is 1 by 5. They ask what is the probability, find the probability that she did not hit a boundary. So, did not hit a boundary means probability of E complement. Okay. So, probability of E plus probability of E complement. Last year itself, I gave all this formula and all. Probability of E plus probability of E complement. An event happens or do not happen. The sum of this as 1. So, probability of E complement is what, children? 1 minus probability of E. Here, do not hit a boundary, that represents probability of E complement. Therefore, probability of E complement is 1 minus probability of E is 1 by 5. So, 5 as an LCM, 5 minus 1, 4 by 5. So, you will get the answer as 4 by 5.